We have covered almost all the questions for J and Nick's point of view. So if you have gone through it, so definitely we cover all the concepts. Okay, I had included all the concepts of a rotation, circular motions, including vertical circular motions. Okay, remaining some questions I have to complete it. So we are moving ahead for next questions. So I covered this question already. So next we are moving ahead for next question. This question already I completed again. So this question is already done. You can do it again. So now we are moving for next question. Yeah. So in these questions, we have list one, list two, and this we have to match it all. So this. So you need to find out correct answer. So from here, if we see the correct answer is going to be first one. So for why first one correct answer? Because the conservation of angular momentum. If we are talking about conservation of angular momentum, the torque is zero. Okay. Next, uniform circular motion. Uniform circular motion, kinetic energy is constant means same. If we are talking about angular displacement, so angular displacement have no dimensions, no issue. And torque. So if we're talking about torque, so torque is basically what? Force. So this question is based on basic understanding. So if you understand basics, okay, so definitely you can do all the you will correct all the questions. It's not very will that you can do all the questions and all. So yeah. So next we are moving ahead for next questions. So next questions I'm moving ahead. Okay, so next questions we have is yeah. So next question we have this one. So this question is we have to match list one with list two. So again, we have this, and so this. So we have options, and we try to find out, figure out the correct answers. What is the correct answer here? Yeah. So correct answer is going to be what? Okay, so for these questions, if you see correct answer is going to be fourth one. Why? Because torques, if we're talking about torques, torque is what? Tau is what? I into alpha, no problem. Okay, if we're talking about angular momentum is so L is what? I omega, no problem. If you're talking about rotational kinetic energy, what? Rotational kinetic energy, what? L omega, you can say 1 by 2 L into omega. So basically L is what? I omega. 1 by see 1 by 2 L is what? I omega into omega. So this is what? 1 by 2. And if you solve it, so this is going to I and omega square. No issue. And if it have work done by centripetal force, so this is going to be centripetal force work done is 0. Yeah. So you can do this question like this. Now we are moving ahead for next questions. Okay. So next questions I have is this one list two. So try to match out this. So this one, this. So match it to match it. So from here, if you try to find out the correct answer will be okay. The second one. Why second one is the correct answer? Because centrifugal force of rotation, centrifugal force of rotation away from fugal means away from the center. Basically, I'm talking about away from the center. So this okay. Now I'm talking about centripetal force. So centripetal force is towards the center, no problem. And now I'm talking about tangential force of center of rotation. Tangential force is the tangential force along the axis. Okay. And angular velocity, okay, changes. Okay, changes. So this is the thing. Okay. So basically, I had to write it properly, but yeah. So this options you can go it. Okay. So no issue in it. Yeah. So next questions I'm moving ahead. Next question I have list one, list two. This is the options we have. So we have the options this one and the correct answer from here. Again, going to the third one. So see moment of inertia. So moment of inertia is basically what tensor. Momentum is a tensor. Okay, and angular acceleration. Angular acceleration I'm talking about that is pseudo. Angular acceleration is pseudo vector. Angular acceleration is pseudo vector. Angular momentum is what? Angular momentum. So if you see angular momentum, so Planck's constant, try to check the dimension of angular momentum. Planck's constant will come outside. And angular displacement, okay, angular displacement is for radian. So basically, you can do this question by elimination method as well. No issue to solve all the parts. Yeah, but you should know the concepts. Yeah. Next question, I'm moving ahead. Next question, so I have this. So this. So and so basically, this is based on unit. So correct answer for this question is going to be first one. So angular acceleration dimension is obviously radian per second square. Now I'm talking about moment of inertia. Momentum is a kg per kg meter square. We're talking about torque. So torque is going to be Newton meter. Angular momentum, joule and second. Okay, angular momentum, joule second. You can check it. It will come out the same. Yeah. So next question, I'm moving ahead. Next question, I have this. So, in this question, when a body is wheeled in a vertical circular such that its total mechanical energy constant with critical velocity, then tension in the string changes with time. So, arrange the following increasing order of the tension when a string is horizontal, a string makes angle 0 degree width, okay, downward vertical, a string makes angle 180 degree downward vertical. This is downward vertical, so a string makes 0 degree width, means a string is like this, and 180 degrees, a string is like this, okay. A string is like this, and vertical, a string is horizontal like this. So you need to find out the arrange when a body is reeled in a vertical circle such that it's so basically you are reeling the body by wrapping out the string on it. Okay, so this is going to be the situation. So in these situations, you need to arrange this in order. So we have the order here. So try to arrange the order. Yeah. So we have the order here. So this. So correct answer we need to find out. So basically arrange the following increasing order tension. So increasing order tension, least tension will be here. Increase ST makes an angle of 180 degree with downward vertical. Okay, so the tension will be least. Obviously here the tension will be least. Okay, then if you come to the fourth ST makes angle 120 degree with the downward vertical. So 120 is somewhere here. Okay, somewhere what here. So then and first one string is horizontal here. And when the last string makes 0 degree, so obviously here makes here the tension is maximum. Even in vertical circular motion, you see the tension is maximum downward situations. Next question, I have identified the correct order in which the value of moment of essay increases, moment of solid is zero. It's easy questions, you can do it. Okay, so this. So we have the so correct answer will be, so if you see the options, moment of of uniform disk of mass and radius are about its diameter. You can check it one by one. So this is going to be then, okay, the moment of inertia of uniform cylinder of mass and velocity on axis of rotation. This, okay, so you need to arrange increasing order. And after this, it will come moment of solid sphere of mass and radius are about its diameter. You can check it. And afterwards, moment of inertia of a ring of mass and radius are about its tangential perpendicular to its plane. It's easy questions. You can do dual questions. You can do it. So our order will come first only. So it's correct. No issue. Next question. I am moving ahead. The following motion is based on the law of conservation of angular momentum. So this the correct answer is, so basically here if you see a person rotating on a table, person on a rotating table, this is conservation of momentum, no problem, angular momentum. This is the law of conservation of angular momentum. Okay, dividing of diver. Okay, so this is also conservation of angular momentum, no rotation of a balloon transfer on a surface. Okay, a solid sphere that rolls down inclines. So no, here no. So this is going to, you can go with first, second, and third. Okay. Next question, I'm moving ahead. Next question, I have identify the correct order using the radius of ratio of radius of gyration to the radius and decreases to the following bodies. So radius of gyration and to the radius. Okay. So you can do one by one, rolling down the cylinder and out. So correct answer from here will come. Third one, that is radius decreases from the following body. So gyration to radius decreases for the following body. You can solve this question. You can in order you can get this answer. It's no issue. You can do the questions. You can do this questions. Radius was already explained. I equals to mk square. When the following bodies of same radius starts rolling down the same inclined plane, identify the decreasing order of their times of descent. I already taught you that acceleration is what g sine theta. Acceleration is what g sine theta divided by 1 plus I by mr square. So from once acceleration comes, acceleration is high, time is less. Acceleration is high, time is less. So by this way, you can solve this process easily, no issue need. So this. So this. So correct answer will be if you check it. Okay. So in times of descent, okay, time of in order of their time of decreasing. Decreasing means more time will be taken. So less time will be taken by solid sphere. You can check it. You will go get the correct answer for this question. Who when the following bodies having radius starts rolling down on the same inclined plane, and for increasing order the acceleration. I already did this question many times. You can do these questions now. So easy questions. Now I'm moving ahead. When a ring is rolling, B1, B2 velocity on the topmost point, lowest point, and end point of horizontal diameter, center of the ring, respectively, the decreasing order of their velocity. Again, this is easily question. So ring is rolling. So rolling. So if you see first, see the topmost point. Topmost point is V1. So decreasing order, so maximum will be at V1. Maximum will be at V1. It's very good question. You should know these questions. So next question, I'm moving ahead. The decreasing order of fraction of total kinetic energy associated with translatory motion of the following bodies is. So, kinetic energy associated, fraction of total kinetic energy associated with the translatory motion of the following bodies is, this decreasing order. Basically, you have to fraction of translational kinetic energy. Fraction of translational kinetic energy means divided by total energy. Yes or no? Divided by total energy, and you have to arrange it in decreasing order. You have to arrange in decreasing order. So this correct answer will be this one. So if you see, but most mode will be for a circular ring. It will be most, and then afterwards it will be hollow sphere, and then afterwards it will be circular plate, and afterwards it will be solid sphere. It's easy questions. Again, it's doable questions. You can do it. Okay, next question. I'm moving 18 omega 1, omega 2, omega 3, omega 4 are angular velocities of rotation of rotating of Earth second, hand, minutes, hand, hours, and watch respectively. Then these values in decreasing order is so angular velocity for rotating of Earth second, hand, minutes, and hours, hand of watch respectively. And the decreasing order, so person is talking about okay respectively this and hours, hand, and watch respectively. Then the value of decreasing order is question talking about decreasing order. So omega 2, omega 3 less than omega 4 angular velocity. The question is basically talking about angular velocity. So you have to arrange in angular velocity in decreasing order. Angular velocity in decreasing order. So if you see these questions, okay, angular velocity for rotation of the Earth. Okay, so rotation of Earth is omega 1. So omega 1 is going to be less. Okay, omega 1 is going to be less. It's easy questions, human questions. Second hand, minute hand, and hours hand. So this second hand means second hand. So this is omega 2. So obviously omega 2 will be more. Omega 2 will be more. So that's why you can do this question by elimination. If you say no, here is omega 2. No, here is omega 2. The easy questions, dual questions, very good questions. If you know these questions, okay, this will create you the good types of sense of concept in your brain. Next question I'm moving. I have this. We have match one, list one, all this thing, match two, list two. Again, I have these options of it. So out of this answer key will be so I'm showing the answer key. Yeah. So answer will be second here. So we are talking centripetal force. Centripetal force. I'm talking about centripetal force change the direction of velocity. Centripetal force changes the direction. Basically, direction is changing. No issue in it. Centrifugal force. Actually, I'm talking about centrifugal force. So centrifugal force is radially outward. No issue in it. I'm talking about torque. So torque is what parallel to the axis of rotation. No issue in it. Now I'm talking about tangential force. Tangential force is changes magnitude of velocity. Changes magnitude of velocity. That's tangential force. Yeah. So it's very good question, normal question. You can do anyone can do this question if you know the basics. Okay, definitely you can solve the questions. Next question, I'm moving ahead. For next question, if R radius K is the radius of direction, then in case of the following body, only what is K square is to R square. This is very famous question again. K square is to R square, K square is to R square. This. So for this question's correct answer will be fourth one. Basically, what I'm going to solve a sphere. If you could see the solid, if you solid a sphere, radius is 2 is to 5. So the K square by R square is basically nothing. You write momentum in as mr square. This coefficient. Suppose I'm writing here 4 by 5. So 4 by 5. This constant is the K square by R square. K square by R square. So on the same way you can check it solid cylinder. So solid cylinder it's going to be what? Solid cylinder. Okay, so solid sphere we have this solid cylinder is this. So 1 is to 2. And next afterward hollow sphere. So hollow sphere is going to be what? 2 is to 3. And afterwards, so hollow cylinder is going to be ring. Ring. So ring is what? MR square 1 is to 1. So it's very good question. Generally, it's a very good question for J points of view. You can solve this question very easily. You know the concepts. Next question, I'm moving ahead. We have a list one, we have list two. So this. So we have to find out the correct answer in this equation. The angular momentum goes to Planck's constant. You can check the dimension, you can check it. Okay, so if you angular momentum and Planck's constant have same dimension, check it once. And if you're talking about torque, so torque have a dimension of same, that is work. I'm talking about angular velocity. Angular velocity is same of frequency, and angular displacement. Angular displacement has no dimensions. Angular displacement has no dimensions. So on this way, you can solve this question. So I hit next question. I'm moving ahead in the case again. The ratio of rotational kinetic energy total kinetic energy. So again, you have to divide the rotational kinetic energy to the total kinetic energy. Basically, what I'm talking about rotational is what I omega square divided by I omega square plus of half mv square. So there are so many ways to solve this question, so many tricks for solving these questions. Okay, so I'm showing you the answer. You can try to find out the correct answer. So if you find out the correct answer will be third one. So for hollow sphere, its ratio is going to be hollow sphere ratio is going to 1 is to 3. Hollow sphere ratio is going to be 1 is to 3. Am I right? 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 So this you can think like this 1 minus 2 by 3. Basically, this is going to 1 minus 2 by 3. So 3 minus 2, 1 by 3 like this. 1 minus. So rotational to the total. Rotational to the RT. Rotational to the total. Rotational to the total. 1 minus of this. On the same way, if we are talking about solid cylinder. So solid cylinder, okay, is going to be what? Solid cylinder is going to be what? Solid cylinders. You are wait a second. Yeah, I did this. Yeah. So basically, yeah, no, don't do 1 is to directly we can take now hollow sphere. So hollow sphere is 2 by 5. That is the case for the R square again. So hollow sphere, hollow sphere. So hollow sphere. Okay. It's okay, okay, you do manually, no issue in it. Okay, so whole square is going to 2fi solid cylinder. Solid cylinder is going to be 1:3, and here solid square here it is going to be 2:7, and whole square is going to be 1:2. So you can do this question manually. Now I'm moving ahead for next question. Next question I have, this is a statement type question. Each of the following statement one given, and these instructions I'm going to follow. Statement one is true, and two is true and explanation, and two is true but not explanation. One is true, two is false, one is false, two is true. So we are moving ahead for the next questions. Questions we have. Statement one: the drive of a car moving with velocity v, when suddenly sees a broad wall in front of him at a distance, it is better to take turn with uh, the. So this the driver of a moving with the speed v, when suddenly sees the road walls in front of him at a distance, it is better to take turn with out applying brakes. And so distance, it is better to take a turn without so it's a question is taking, if you see the walls, to take turns without applying the brakes. So this is first one, and second one is when the car takes a turn, frictional force between tires and road supplies necessary centripetal force. So for this, what is the correct answer? For this, what is the correct answer? So if you see the these questions, this is totally wrong. First one is totally wrong, and this one is if you see the when the car takes turn, friction between the tires and road supplies necessary centripetal force. This is very good questions. So you can think on this. We are moving for next questions. Okay, then we'll continue. Yeah. So this is questions. Okay, think on these questions. What will be the correct answer?